So in this video, we're going to examine the relationship between molecules and elements in chemical equations. So let's examine this equation right here. All balanced, 1 H2SO4 needs 2 NaOHs to make 1 Na2SO4 and 2 waters. Well, what's that saying? Traditionally, we have thought, oh, it must be saying that one molecule of H2SO4 will make, or well, actually requires 2 molecules of NaOH. And that's true. 2 molecules of H2SO4 will need 4 molecules of NaOH. Let's step that up. 12. Wow, that's 24 molecules. Now, we can do this in our head, but what we actually did was a conversion. We said 12 molecules, and remember there's no abbreviation for molecule, H2SO4. Well, I know that I know that one molecule from up above in the balanced equation, H2SO4, needs 2 molecules of NaOH. So we put that in there, and we came up with 24 molecules of NaOH. Let's take that a step further. What if we had 6.02 times 10 to the 23rd molecules of H2SO4? How many NaOHs would we need? Well, let's see, 6.02 times 10 to the 23rd molecules, H2SO4, when one molecule of H2SO4 needs 2 molecules of NaOH. So we do the math. Oops, finish it up. Do the math. 1.20 times 10 to the 24th molecules of NaOH. Well, you may recognize the number we've been using. Does anyone remember what that is? That's 1 mole. So we can actually substitute in moles instead of molecules and treat these as mole relationships. Because remember, mole is just a counting number. So let's take a step back and see what that shows us. When we look at a balanced chemical equation, we can see the relationship between reactants and products, or 2 different reactants, or 2 different products, but more importantly, we can look at the relationship as it relates to molecules or elements. How many? I have 3 molecules. Or we can scale it up to moles. And I promise you, using moles is a lot better than using a lot of scientific notation. So stoichiometry is the math of chemistry that allows us to determine the amounts of both products and reactants in a chemical reaction. We'll be using dimensional analysis. You need to do it exactly like I show you. Specifically, we'll be using the mole ratios. The mole ratios are actually the things that convert one substance to another because we know the relationship. For example, 1 is to 2 as 2 is to 4. It gives us a relationship. So let's write all the mole ratios we can. 1 mole of H2SO4 to 2 moles of NaOH. I'm just writing it in this ratio form. Another one I can write is 1 mole H2SO4 to 1 mole sodium sulfate, 1 mole H2SO4 to 2 moles water. And I can write them the other way. I can say 2 moles of NaOH on the top and 1 mole of H2SO4 on the bottom. But right now I've got 3 ratios. So let's do some more. 2 moles of NaOH, draw a line there, to 1 mole of sodium sulfate, or 2 moles of NaOH to 2 moles of water. And this is very important. Do not reduce mole ratios. Let's write this up here. Do not reduce mole ratios. Okay. We have one more to write, and that's the product mole ratio. So 1 mole of Na2SO4, 2 moles of H2O.